Hey there, and welcome. Today we're diving into something that's literally all around you, but totally invisible. It's the secret sauce behind your phone, your computer, your entire digital world. We are talking about the bit. And that's not just some fancy quote. It's the absolute truth. If you can wrap your head around this one simple idea, you basically have the key to understanding, well, everything. From how a text gets to your friend, all the way up to how AI works. Think about it. Every single photo you take, every song you stream, every message you send, it's all made of the exact same stuff. But what is that stuff? We hear these words all the time, right? Megabits, gigabytes. But what are we actually talking about? Let's dig in and find out. All right, so let's get right to it. What is this thing? We're going to break it down to its absolute core. Think of it as the atomic particle of information. Okay, so the word bit is just a mashup of binary digit. And here's the crazy simple part. It's the absolute smallest piece of data you can have. It only has two possible values. It can be a 0 or it can be a 1. That's it. End of story. But you might be thinking, how does an idea like 0 or 1 actually exist inside my phone? Well, it's all about physical states. A 1 could be a tiny little switch flipped to on, and a 0 is that same switch flipped to off. Or on a hard drive, it might be a tiny magnetic area pointing north for a 1 and south for a 0. It's just a physical representation of two different states, high voltage versus low voltage, yes versus no. That's all it is. Okay, so one bit by itself, honestly, it's not that exciting. It's just a yes or a no. The real magic, and I mean the secret to our entire digital universe, is what happens when you start lining them up together. This is where simplicity explodes into unbelievable complexity. So let's start small. One bit gives you two choices. That's it. Think of a single light switch. It's either on or it's off. Simple. Now let's add a second light switch. Suddenly, things get more interesting. You don't just get one more option, you get double the possibilities. You can have both off, the first on and second off, the first off and second on, or both on. That gives us 4 unique patterns: 0, 0, 0, 1, 1, 0, and 1, 1. Okay, now for the big jump. What if we line up 8 of these switches? The number of combinations just explodes. It grows exponentially. With just 8 bits, you suddenly have 256 different patterns you can make. And guess what? That's enough to give a unique code to every single letter, A to Z, both uppercase and lowercase. All the numbers from 0 to 9, and all those symbols on your keyboard like the exclamation point and the @ sign. This group of 8 bits is so important, so useful, that we gave it a special name. You've definitely heard this one, the byte. The byte is kind of the fundamental word, if you will, in the language of computers. It's the standard package for things like a single letter of text, and it's how we measure memory. So what happens if we just keep adding more bits? The power of this is just incredible. Let's take 24 bits. That gives you, wait for it, over 16.7 million unique combinations. And that's not just some random huge number. That's the magic number for what we call true color in digital images. It means we have enough combinations to assign a unique code to 16.7 million different colors for every single tiny dot, every pixel in a photo. Okay, I know this can all sound a little abstract, just a bunch of ones and zeros, so let's make this super tangible. Let's see how the bit shows up in the tech you use literally every single day. All right, so you type the word cat on your keyboard. What's actually happening under the hood? Well, your computer doesn't see letters, it sees numbers. It looks up a universal dictionary, something called ASCII, and sees, okay, a capital C, that's the code 01000011. Then A, that's 01000001. And T is 01010100. So for the machine, the word cat doesn't exist. It's just a string of 24 ones and zeros in that specific order. What about internet speed? You hear about megabits per second all the time. What does that actually mean? Well, when your internet provider says you have a 100 megabit connection, they're literally saying their network can send 100 times a million of those tiny on or off signals, those bits, down the wire to you every single second. That's all it is. It's just a measurement of how fast that river of bits can flow. And storage. When you go out and buy a 1 terabyte drive, what are you actually buying? You're buying the physical space to store roughly 8 trillion individual bits. That's 8 trillion tiny little switches that can be flipped on or off to remember the data for all your photos, your documents, your games. It's staggering. For like the last half century, the whole game in computing has been simple. Make the bits smaller and cram more of them closer together. Smaller and faster.
But we're starting to hit a wall, a very real, very physical wall.
You see, when you try to make these switches, these transistors, the size of just a handful of atoms, the universe starts to get weird. The laws of quantum physics take over. Electrons can literally just teleport through barriers they're not supposed to cross. This causes a bit that should be a 0 to randomly flip into a 1. You get errors. We just can't shrink them down much more using the old rules. So what's the solution? Well, the brilliant idea is, what if we stop fighting quantum mechanics and start using it? And that brings us to the next big thing, the quantum bit, or qubit. Now this is where it gets a little mind-bending. A normal bit has to be a 0 or a 1. It's definitive. But a qubit, well, a qubit can be a 0 and a 1 at the same time. It's in something called a superposition. The best analogy is a spinning coin. While it's in the air, is it heads or tails? No, it's kind of both. It only becomes one or the other when it lands. This completely changes the game from a world of certainty to a world of probability, and it could unlock a level of computing power that's almost impossible to imagine. And so that leaves us with this final big question. The good old-fashioned bit, that simple on-off switch. It built our entire digital world. It gave us everything from calculators to the internet to artificial intelligence. So if that's what we managed to build with simple black and white certainty, what kind of world will we build with the strange, new, powerful language of probability? The next chapter is just beginning. Thanks so much for watching.